This video is for lesson 5.3, starting at example 3. If you haven't done example 1 and 2, you should watch the previous video. So in example 3, we are solving rational equations, but this time these rational equations are going to have two solutions. And we're going to look at both cross multiplication and using the least common denominator to solve. We used both of those methods on the previous page. So in example 1, we cross multiplied. In example 2, we multiplied by the least common denominator. We're going to start with the least common denominator first. So in this problem, we have 1, which is equivalent to 1 over 1. And we have 8 over 5 minus x, and we have an x. So our LCD is 1x times x minus 5. You'd also just write it as x times x minus 5. So we are going to multiply that to both sides of the equation. So I have x times x minus 5 times 1 minus 8 over x minus 5 equals, clear up some space, equals 3 over x times x minus 5. And again, you can write it like this, or if you want, you could put it over 1, if that helps you. All right, now it's time to distribute. So I'm going to distribute x times x minus 5 to the 1, and then distribute it to 8 over x minus 5. So I have x times x minus 5 times 1, but I don't need to write the times 1, minus x times x minus 5 times 8 over x minus 5 equals 3 over x times x minus 5. And I can just make that one big fraction because we know when we multiply fractions, we multiply across the top and across the bottom. And now we're ready to do some canceling. So on the left-hand side, x minus 5 and x minus 5 cancel out. On the right-hand side, x and x cancel. So this leaves me with x times x minus 5 minus x times 8 equals 3 times x minus 5. So that gives me x squared minus 5x minus 8x equals 3x minus 15. So be careful to distribute. Then this is x squared minus 13x equals 3x minus 15. Because this is quadratic, I want to set it equal to 0. So I'm going to subtract 3x from both sides and add 15. So subtract 3x, add 15. That gives me x squared minus 16x plus 15 equals 0. Now you could factor mentally, or you could make a diamond with 15 as your a times c value and negative 16 as your b, which means this is going to be negative 15 and negative 1. So we have x minus 15 times x minus 1 equals 0. Set each factor equal to 0. You get x equals 15 and x equals 1. Now remember, I should always check my work. So I would want to plug this in and make sure that both my answers check out. We're going to do that a little later. First, I want to look at how do we solve this problem using cross multiplication instead of using the LCD method, because we want to be comfortable doing both. So I'm going to clear the page, and in your notes there's a section that says using cross multiplication. You can take your notes over there. I'm actually, instead of doing them here, I'm going to go back up to the top so we can see the problem, and we are going to solve using cross multiplication. So looking at the original problem, we can't cross multiply because you can only cross multiply when you have two fractions equal to each other, so two ratios, so a over b equals c over d. In order to get to that, I need to combine these two things. In order to add those together, I would have to have the same denominator. So I'm going to change 1 so that it has the same denominator as 8. So this would become 1x minus 5 over x minus 5 minus 8x minus 5 equals 3x. I don't need to change the denominator on this side because this is already just a single fraction. The thing that I need to combine is this left-hand side. These two need to be combined. So now that they have the same denominator, I can combine them. I have x minus 5 minus 8 over x minus 5 equals 3 over x. If I keep simplifying, that is x minus 13 over x minus 5 equals 3 over x. Now I can cross multiply, so I get x squared minus 13x equals, and then 3 times x minus 5, so 3x minus 15. If you wanted to show the step in between where you have x times x minus 13 equals 3 times x minus 5, you of course could do that. I just went straight to distributing. All right, let's finish solving this. So again, it's a quadratic, so we need one side set equal to 0. So I'm going to subtract 3x and add 15. Subtract 3x, add 15. We get x squared minus 16x plus 15 equals 0. It's the same quadratic we got when we used the LCD method. So x minus 15 times x minus 1 equals 0, and x is 15 and 1. So both methods got us the same answers. They're just two different methods. Now let's move on to a check step here. We always want to make sure that we are checking for extraneous solutions. The two solutions we got were x equals 15 and x equals 1. So I can plug these in. 1 minus 8 over 15 minus 5. Is that equal to 3 over 15? Well, this is 1 minus 8 over 10 equals 3 over 15. If we simplify the left-hand side, we get 2/10. If we simplify 3 over 15, we get 1 over 5. And hopefully most of us can recognize 1 over 5 is the same thing as 2 over 10. So that checked out. Let's check it for x equal to 1. So 1 minus 8 over 1 minus 5, is that equal to 3 over 1? Well, 1 minus 8 over negative 4, is that equal to 3? 1 plus 2, because a negative times a negative is positive, is equal to 3. So it checks out. The shortcut to all this, as a check step, instead of plugging everything in and solving to make sure they're equal, you can just actually check the denominators and make sure that your answers don't create a denominator of 0. So if I plug 15 into x minus 5, my denominator is not 0. If I plug it in for x, my denominator is not 0. So 15 will work. If I take x equals 1 and I plug it in here, my denominator is negative 4, not 0. Here the denominator is 1, not 0. So both of these will work. Okay, on to the next example. In your notes, it's labeled example 5. It should really be example 4. But again, we're going to solve a rational equation with two solutions. Since this is a ratio equal to a ratio, we can just cross multiply. We could also use the LCD method. It is up to you which one you prefer. I'm going to show the LCD method. In this case, the LCD is maybe hard to determine in the first step. We're going to need to factor and see what the denominator is on the left. So it's x times 1 minus x, or if I factor out a negative, this becomes negative 1 plus x, which is the same thing as x minus 1. And I like this version because x minus 1 shows up in our other denominator. So I'm going to rewrite this fraction with that LCD. So we have negative 2 over x minus 1 equals 1 over x minus 1. I'm going to multiply both sides by the LCD, which we said was x times x minus 1. So I get x times x minus 1 times negative 2, I do need parentheses there, over x minus 1, equals 1 over x minus 1 times x minus 1. All right, we can start canceling. So x and x cancel, x minus 1 and x minus 1 cancel, x minus 1 and x minus 1 cancel. and I am left with negative 2 equals x. So that worked out really nicely, and we're done. Sometimes the LCD method is longer, sometimes it's shorter. Okay, so let's see what would have happened if we had done cross multiplication. I would have had negative 2 times x minus 1 equals x minus x squared. So negative 2x plus 2 equals x minus x squared. It's a quadratic, so I want to set it equal to 0. I would rather my a value be positive, so I am going to add x squared to both sides and subtract x. So I get x squared minus 3x plus 2 equals 0. Factor, I get x minus 2 times x minus 1 equals 0. So x equals 2 and x equals 1. Now we need to check our solutions and make sure that they work. So if I go back up here and plug in 2, I'd have 2 over 2 minus 2 squared. I'd have 1 over 2 minus 1. Do either of those have a denominator equal to 0? No. So x equals 2 is fine. If I plug in 1, so let's make space. So negative 2 over 1 minus 1 squared and 1 over 1 minus 1, these denominators are equal to 0. So x cannot equal 1. This is not a true solution. It is an extraneous solution. So the only true solution is x equals 2. All right, now it's possible to check our work graphically, so you should grab a graphing calculator at this point. And the way we solve this, or check it on our calculator, is to treat each side of the equation like a separate equation. So in y1, I'm going to put this left-hand side. So I put y1 equals negative 2 over x minus x squared. And when I do that, I get a graph that looks like this. Something like this anyway. Okay, then in y2, I take the other side of the equation, 1 over x minus 1. Now, from what we know about rational equations, there's going to be a vertical asymptote at, so that should be a colon there, at x equals 1. So I'm going to put in just a little bit of a dashed line here. Okay, so when I graph this on my calculator, I get something that looks like this. And then the second equation comes below and crosses over like this. So I can tell 1 won't work because there's a vertical asymptote at x equals 1. I can tell 2 is a solution because if I do second calc and choose number 5 intersect, it will find an intersection point here at 2, 1. So x equals 2 is a solution. It is where these two equations meet. It is where these two equations are equal. So x equals 2. So that's another way to check our work. One final graphing example is example 6. So when this rational equation is solved algebraically, you get x equals 2. We can use a graphing calculator to determine whether or not the solution is extraneous. So I could graph this equation, or this equation has two separate equations again, so a y1 and a y2, and look for a point of intersection. If I do that, my calculator isn't going to find one. That's my first hint that x equals 2 is an extraneous solution and not a real solution. So you could sketch a graph of that if you wanted to in your notes. It would look something like, this, make that a little curvier. Let's start that over. It would look something like this, and then like this. So that would be your y1, y2 would come down over here. Oops, on the other side. Should come down on the other side, over like that, and then run just above. So they never intersect. Another way to check that is we could go to the table and go to x equals 2. Actually, in the table, look like this. So your y1 and your y2 values. When x is 2, you get error and error. That means there's a vertical asymptote there, and there cannot be a possible solution. So for this problem, no solution. So make sure you grab your calculator if you haven't already and actually check that that's what you get. All right, that's all for now.